the lipids. Lipids is something you want to crave for sometimes, or most of the times. And in our busy world, this is very accessible. Now let's talk about lipids. Lipids are large, diverse, and mixed bag of organic compounds. And fats and oils are the typical example of these lipids. This can be found in plants, animals, and microbes. In human beings, this is the most common component of the nervous system. And there's abundant of this, particularly the triglycerides, the phospholipids, and the steroids. Now, lipids are known for their properties, and that is based on their structural similarities and preponderance of nonpolar groups. And generally, lipids are classified into two main groups. And one of that is at the right side, the open chain compound with a polar head and a long non-polar tail. And common examples are the fatty acid, the triglycerides, and the glycolipids. Now, the second common structure is that of the fused ring compounds that is composed of steroids, such as the cholesterol. Let's look into the details of the open chain compound and the fused rings. This is how it will look like chemically. Lipids consist of 3 atoms, mostly the carbon, the hydrogen, and the oxygen. Where in formula, you may look at it as carbon is 57 in number and hydrogen is the most numerous with 110, and oxygen being the least. In a ball and stick appearance of an open chain, we can divide it into a polar head at the left side and a long chain at the right side. Now, the middle is being composed of a black ball and a chain of carbon. This is what we call the carbon skeleton. And attached to the carbon are the hydrogen, which when combined with the carbon will create what we call the hydrocarbon chain, the long chain of hydrocarbons. And this consists the tail part, which is hydrophobic and nonpolar. Now, at the left side are 2 oxygen, which serves as a polar head and negatively charged, and what we call hydrophilic in nature. And this is how it will look like. And right below is the appearance of a fused ring, which is composed of a lateral side of carbon and hydrogen in the middle. And this appears to be an appearance of ring shape. There are the fused ring compounds, from which fused rings are representing steroids and cholesterol the most, and the open chain represents the fatty acid, the triglycerides, and the glycolipids. Triglycerides, triacylglycerols, and the neutral fats. This is one of the classification of lipids. Triglycerides is an old name, and triacylglycerol is the most recently way to address this. And neutral fats is a common name. Now, triglycerides is being composed of a building blocks of 2 components, the glycerol and the fatty acid. It is so called as triglycerol because there are 3 fatty acids in 1 glycerol. And this is how it looks like. Now, this is the glycerol part. And chemically, at the right side, you may see here the carboxyl group having the carbon and 2 oxygen colored red. One is with a single bond and one is having a double bond. And at the left side is having the ester group, the carbon attached to 2 hydrogen. And they together form an alcohol group, which there are 3 of them. Now, the glycerol part is the polar head and negatively charged. This glycerol, or the polar head, is being added with the fatty acids, and there are 3 of them. Now, this is now a triglycerides. And if you will look at the left side, is the polar head being combined, 1 glycerol as a common, and 3 fatty acids connected. At the end of the triglyceride is a methyl group represented by that H, and at the left side is an acid group. And further, if we will look at the backbone, here it is. And if we will look at the ball and stick model, this is how it will look like. And much more. If we will dissect that, we can separate the head as known as glycerol, and we can connect the fatty acid as one and another, and that completes the 3 fatty acids in 1 glycerol. Now, triglycerides can be found in animal and in plants. If it is in animal, then we call it as a fats, and fats are solid triglycerides. And mostly, if fats are being dissolved, or a triglycerides that is a liquid in form, is called an oil. And this can be found in the subcutaneous tissue of the body and even around the organs. Normal triglyceride is good, but in excess of that will lead to a lipid overdeposition, such as this. You're now having a handle, and this is nasty. And nurses must be able to know and understand and interpret an important lipid profile, and that nurses must be able to interpret the normal values, such as a normal triglycerides will be less than 150, with having a unit of milligram per deciliter. And the worst case scenario, a very high, will be 500 or higher. Now, in our health teaching of achieving a healthy lifestyle, this is not what we are supposed to advise, but rather we should advise our patient to get rid of that nasty fats and live a healthy lifestyle as a way of healthy living. The types of triglycerides. There are 4 of them: the saturated, the unsaturated, the trans fat, and the omega-3 fatty acids. But at this slide, we will focus on the saturated versus the unsaturated. Let's take a look. Now, saturated triglyceride is best described as having a long straight chain. And that long straight chain is said to be straight because this is unbranched. There's no break. There's no bend. There's no kinking. And most especially, you have to focus on a C to C, or carbon to carbon covalent bond in between them. From the beginning, you may see that there's a single covalent bond that connects one carbon to another carbon, and to another carbon, and to another carbon, until the end tail, from the beginning to end tail. And what is something remarkable about saturated fat is that there is a fit, close, regular pattern of their long chain. I mean, they will go up and down like a wave, and the thing is they can be packed together, arranged together in a compact state, such as what we are seeing in a butter form when they are in they appear to be solid in state together with the animal fats, and this is a lovely lunch. Now, their difference between unsaturated fat is that unsaturated fat is exactly the opposite of saturated fats. And that you may see that it's no longer a straight chain. There is a bent, there is a breakage, and there is a branching, a kinking. And this is because of a double bonding that happens between a carbon to carbon, and at this point it happened at the 8th to 9th carbon pattern. And this kinking may happen not just once, but may happen twice. And this is the classification of unsaturated fats, such as monos unsaturated fats and the polyunsaturated fats. If the carbon to carbon double bonding of covalent happens once, this is what we call the mono unsaturated fats or triglycerides. But if the cobalt to cobalt double bonding happens twice then and more, we can call it as the polyunsaturated triglycerides. Now, what is remarkable about the unsaturated fat is that there is a presence of either a cis double bonding or a trans double bonding, which I will discuss in the next slide, and which plays a very important role. Now, the poly or the unsaturated triglycerides is most commonly found between or among the plant source of oil. As to the question of which is healthier, is it the saturated or the unsaturated fats or triglycerides? Now, the word saturation would mean a point of question as to what saturates the triglyceride. And this is answered by the hydrogen mostly saturates the triglycerides. So it's not the carbon, it's not the fats, it's not the oil, but it is the hydrogen that saturates the triglycerides. Now, in the next slide, we may see that there are sources of unsaturated and saturated. From the unsaturated source, as I have mentioned, the plant source is the best source. And you may name it as having canola, safflower, sunflower, corn oil, olive oil, soybeans. And as you look at the saturated fat level, it is from a low to an increasing pattern. Much more. That is being represented by a yellow color percentage of saturation. And that is as you go longer and higher in percentage, this becomes unhealthier. Now, if we will look at the lard, these are the animal fats that is classified as highly saturated. The palm oil, the beef tallow, the butter fat, and the coconut oil. This may be left unnoticed at all times. Coconut oil is not that good because it has a very high level of saturation, 92%. And you may see from the right, the blue color is having the polyunsaturation with a varying degree, and the monosaturation fat. Now, at this slide, I would like to give emphasis on the unsaturated fat. The unsaturated fat, which has a double covalent bond or a carbon to carbon double covalent bonding. And we say if there is no double bonding, then we will call it as a saturated fat. However, if there is one double bonding in any point of the long chain of carbon to carbon, then we will call it as a monounsaturated. And if there are two or more of the carbon to carbon double bonding between the covalent bond, then we will call it as polyunsaturated. And this happens only at the unsaturated types of triglycerides. Now, at the polyunsaturated or at the unsaturated triglycerides, there is another important point to consider in the bend and in the kink that they are making. And these are the difference between a cis double bond and a trans double band. A cis double band in unsaturated fats are just typical form of the unsaturated fat that's found in nature. That's normal. While the trans fat, if there is a trans bonding, trans double bonding, this can be made through hydrogenation. They may just look the same if you will look at it. But let's focus on the cis double bond. Take a look at the right upper corner. There is a double bonding that happens between carbon to carbon in the middle, as illustrated by the white focus area. And you may notice that the hydrogen are both aligned at the lower bottom side of the two carbon atoms. And there is an absence of hydrogen in the upper side chain. However, what happens in a trans double at the lower side, right upper corner on the focus area of white? The hydrogen has been derailed at only one point. And you may find the opposite hydrogen as present and absent at the upper side chain. And that is the difference between a cis double bond and a trans double bond. And a cis double bond may just be considered as normal. However, a trans double bond is a negative or having a negative health effect. And that can be observed in the junk foods that each one of us is very fond of. And due to these negative health effects, the process to make trans fat has been banned in many countries. That is, you have to look at the nutritional level of the foods that you are buying and take a look at the trans fat. Because in our later discussion of trans fat, this is indeed causing a very big trouble to our health. At a molecular point, let us clarify once again the difference between saturated and the unsaturated triglycerides. Now, the saturated fatty acids are having a descriptive characteristic as to having a single C to C bond, and that is, it makes a long chain of triglycerides, fatty acid. They are closely packed, and then there's a strong attractions between chains. And these saturated fatty acids can be found, and common example are the animal fats and the butter. And at room temperature, it forms to be solid, and it will require a high melting point to dissolve the butter. And that is at the point of saturated fatty acid. Now, by looking at the unsaturated fatty acids, it can be described as triglycerides, which has a bent, broken, kink, deranged, long fatty acid, which has a double bonding at any point of the carbon. Double bonding can be 1, 2, or more. Unsaturated fatty acid has one or more double C to C bond and nonlinear chain that do not allow the molecules to pack closely together. That makes it a healthy fatty acids. And there will be few interaction between chains. It has a low melting point, and at room temperature, it is a liquid form. And the most common example for unsaturated fatty acid is that of the plant oil, the olive oil, the sunflower oil, the corn oil, and these are healthy fatty acids. At this point, we will have a final clarification as to between what is saturated and an unsaturated fat, which is healthier between saturated and the unsaturated fat. Now, as previously been discussed, saturated fat has a long chain and straight chain, and there is no double bonding between carbon to carbon, while the unsaturated fat is unsaturated triglyceride is having a double bonding that causes the triglycerides to kink, to bend, and to be broken. And between the question of which is healthier between saturated and unsaturated, let's take a look at the sources of the saturated triglycerides. And these are some lovely stuff that we usually crave for. However, the saturated fats are full of bad lipids, and this would lead to an alteration in our health way of life. However, the unsaturated sources are from the healthy sources, from foods, nuts, and fish. And at this point, to choose between saturated and unsaturated, unsaturated is a healthier sources of lipids than that of the saturated. The phospholipids. It is a major macromolecules that is consist of primarily fats, further made from carbon and hydrogen. Phospholipids has two parts: the hydrophilic polar head, meaning it is negatively charged molecule, water-loving, and internally and externally directed. Second, the hydrophobic non-polar tail, which is uncharged molecule, and it hates water. The hydrophobic tail consists of fatty acids and hydrocarbons, which the left tail is saturated and the right tail is an unsaturated. Together, combining the hydrophilic head and the hydrophobic tail, which are both water-loving and water-hating, they create a characteristic called an amphipathic condition. The phospholipids bilayer. It is an amphipathic layer of phospholipid with a polar head facing outside, upward or outbound, towards the aqueous external environment of the cell, from which another head is facing inside or inward, inbound, facing the cytoplasm and organelles. It further binds two layers of non-polar tail that is in between them, which by such an arrangement, it creates what we call a semi-permeable membrane. The semi-permeable membrane is a selectively permeable barrier which allow and disallow the entrance and exit of molecules in and out of the cell. It is important in homeostasis and in cellular transport.